Welcome to lesson 1.7, find perimeter, circumference, and area. So we're looking at three different pieces, technically, perimeter, circumference, and area. But what you should realize right away that the circumference of a circle is simply the perimeter of a circle. So circumference is just a special type of perimeter when we're dealing with a circle. So really we're looking at perimeter and area for this lesson. Now, as we look at these formulas or equations below, capital P stands for perimeter, capital A stands for area. So we will be looking at these four different figures for their formulas or equations. So starting with a square. In a square, we are calling our side length S. So whatever our side length is, to figure out the perimeter, the equation is simply perimeter equals 4 multiplied by S. So 4 times S. For area, the formula is S to the second power, or S squared. So if our side length was 10, our perimeter would be 4 times 10, or 40. Our area would be 10 squared, or 10 times 10, which is 100. For rectangle, the perimeter of a rectangle is 2 multiplied by the length plus 2 multiplied by the width. So when we look at a rectangle, perimeter, you could say add up all four sides, but 2 of these sides are the length and 2 are the width. So our formula is 2 times the length plus 2 times the width. Area of a rectangle is simply length multiplied by width. Then we get into the triangle. So for a triangle, they are saying we're looking at this triangle with side lengths A, B, and C. H is our height. Now there's something we need to remember when we're dealing with triangles for area. So we're going to look at area first. Area is 1/2 the base times the height. So 1/2 multiplied by base multiplied by height. The way we know what base and height are, our base and height have to meet at the right angle. So whatever side meets the height at 90 degrees is your base. So area of a triangle is simply add up the three sides. So if our outsides are A, B, and C, A plus B plus C. Area of a triangle is 1/2 the base side multiplied by the height. And remember, base and height meet at 90 degrees or a right angle. And then our final figure for today is a circle. So in a circle, we have diameters and radius. So a diameter is any segment that connects two parts of the circle and passes through the midpoint. So diameter goes the whole way across the circle and passes through the midpoint. The radius is always any point on the circle connected to the midpoint. So radius is point on the circle to the midpoint. Diameter is connecting 2 points on the circle through the midpoint. Now, something to remember here is diameter is always twice as large as the radius, or the radius is always half of the diameter. So for circumference, we actually have two different equations we can use. We could use pi multiplied by the diameter. So in a problem, if they give you the diameter to find the circumference of the circle, it's pi multiplied by the diameter. If they give us the radius, the equation is 2 times pi times the radius. So if they give you diameter, it's pi times diameter. If they give you radius, it's 2 times pi times the radius. Now for area of a circle, we always need to know the radius. So if we're dealing with area of a circle, the equation is pi multiplied by the radius to the second power, or the radius squared. So be careful there, it's not 2 times the radius, it's the radius multiplied by itself. So area is pi times the radius squared. So if my radius was 7, the area would be pi times 7 times 7. So example 1 is using a rectangular basketball court, and we're going to look at perimeter and area. So we know the width is 50 feet, and we know the length is 84 feet. So perimeter is 2 times the length plus 2 times the width. So 2 times 84 plus 2 times 50. 84 times 2 is 168. 2 times 50 is 100. Add them together, and our perimeter is 268 feet. You'll notice our units for perimeter are always to the first power. So they're just feet, miles, yards, etc. For area, we have length times width. So we have 84 feet multiplied by 50 feet. That gives us 4,200 square feet, or feet to the second power. So for area, our units are always to the second power. So meters squared, feet squared, inches squared, etc. Perimeter to the first power, area to the second power. Example 2 is looking at a circular patch. So we're ordering circular cloth patches for a soccer team's uniform. They want us to find the approximate circumference and area of the patch shown. So by saying approximate, they mean eventually at the end we'll be rounding our final answer based on the decimal we get. So for circumference, when I look at this patch, they gave me the diameter. The diameter of the circle was 9 centimeters. So it's 9 centimeters across the whole circle. So for circumference, it's simply pi times the diameter. So pi times 9. So that approximately is 28.27 centimeters. For area, it's pi times our radius squared. So if they give us diameter, we have to figure out the radius, which is always the diameter divided by 2. So our radius would be 4.5 centimeters. So our area is pi times 4.5 to the second power. 4.5 squared times pi gives us approximately 63.62 square centimeters, or centimeters squared. So remember, for area of a circle, you always need radius. For circumference, you can use pi or diameter based on what they give you. Now example 3. Example 3 gives us 3 different figures. You'll have to draw part B. But in example 3, it asks to find the area and the perimeter, or circumference, depending if it's a circle, of each figure, if necessary, round to the nearest tenth. So in this case, for part A, we have a rectangle. Width is 5.7 meters, length is 13. So to find the area, it's just length times width. So 13 multiplied by 5.7, which is 74.1 meters. For perimeter, and I actually have my units wrong here, my apologies. This one should be meters to the second power. This one should be regular meters. So you'll want to flip the 2 units. This one should be m squared. This one should be a regular m. So for perimeter, we have 2 times the length, 2 times 13, plus 2 times the width, 2 times 5.7. Multiply first, then add, and you get 37.4, and this should be regular meters, not meters squared. Then we look at B. In B, we have a square. 4 congruent sides, 4 right angles. So in this case, with a square, our area is the length of a side to the second power. So if our side is 1.6, our area is 1.6 squared, or 2.56 inches squared. Now on that one, because it ended in the hundredth, I just left it in the hundredth. I didn't round to the nearest tenth. If I were to round this to the nearest tenth, it'd be 2.6. Now for perimeter of a square, it's 4 multiplied by whatever our side length is. So in this case, 4 times 1.6 gives us 6.4 inches. And then in part C, we have a circle with a radius of 2 yards. So our area is pi times the radius squared, or pi times 2 to the second power. 2 to the second power is 4. 4 times pi is approximately 12.57 square yards. So again, if I were to round this to the nearest tenth, the 7 would round the 5 up, so it'd be 12.6. And then for perimeter, it's 2 times pi times the radius. So 2 times pi times 2. In this case, anytime you have a radius of 2, the area and circumference, or perimeter of the circle, are the same. So our circumference or perimeter, circumference because it's a circle, is 12.57 yards. Now for part D, we need to use the distance formula again. So I just wrote it up here as a reminder. Distance equals, it's all inside of the square root, and it's the change in the x values to the second power plus the change in the y values to the second power. So in 4, they give us triangle QRS, and they give us the 3 vertices. What's the approximate perimeter of the triangle and the area? So first off, what I want to do is just plot my 3 vertices. So I went over 1 up 2, over 5 up 2, over 4 up 6. Got my 3 vertices, so I connect them to create the triangle. Now, right away, I can just look at QS, and I know the length of that side because it's on the same axis here. It's on the same x value. So in this case, I can just count from Q to S 1, 2, 3, 4 places. So QS is 4. What I don't know is the side length RQ and RS. So to figure those out, we will want to use the distance formula. So to find RS and RQ, we want to take the x and y values from the coordinates and plug them into the distance formula. So with RS, I'm using 4, 6 and 5, 2. So change in x, 5 minus 4 squared, plus the change in y, 2 minus 6 squared, gives me 1 squared, which is 1, and a negative 4 squared, which is 16. 1 plus 16 is the square root of 17, or approximately 4.12. Now to figure out RQ, I'm using the coordinates 1, 2 and 4, 6. So change in x, change in y, end up with 4 minus 1 squared and 6 minus 2 squared. So 3 squared is 9, 4 squared is 16. So we have the square root of 25, or 5. So now I can figure out my perimeter once I found my other 2 side lengths. So I have 4 plus 5 plus 4.12, which gives me a perimeter of 13.12 units. Now to find the area, and this is where using the graph paper helps. To find the area, we need to draw in our height. The height would be from our base side to the vertex where it can meet at 90 degrees. So we can connect R to side QS to meet at 90 degrees, and that gives us our purple line here for the height. Then we can count how many spaces from QS up to R, so it'd be 1, 2, 3, 4. So my height was 4. QS, the side it meets at 90 degrees, is our base, so our base was also 4. So the area of this triangle is 1/2 base times height. So 1/2 of 4 times 4. So 1/2 times 4 is 2. 2 times 4 is 8. So we'd have 8 square units. So example 5 is going to be the same thing. I apologize because the coordinate plane did not copy again. But we would want to graph this on a coordinate plane. So you could draw this one up here as well if you have room and can see it. But the first thing we want to do is graph our 3 corners and draw our triangle. So I graphed my 3 points, drew my triangle. I know from E to G, this whole side, I can just get the distance, which is 6 minus 2. So EG's side length was a 4. To figure out EF and FG, I need to use the distance formula. So for EF, change in X, 7 minus 1 is 6. Change in Y, 3 minus 6 is a -3. So we have 6 squared plus -3 squared, which is 36 plus 9, or the square root of 45, which is approximately 6.7. Now for the side length of GF, again, distance formula, change in X values, 7 minus 1 is 6. Y values, 3 minus 2 is 1. So 6 squared plus 1 squared gives us a square root of 37, or 6.1. So to find my perimeter, I would take my EG side of 4, my EF side of 6.7, and my GF side of 6.1, and add them up to get my perimeter of 16.8 units. Now to figure out the area, we have half of the base and the height. Well, if I would go from point F, I can draw in a segment that hits EG at 90 degrees. So that creates my height. Then if this was on graph paper, we could count from this point to point F, giving us the height of 6. Because 7 minus 1 here would give me the height of 6. So this segment's 6 long. So I have a base of 4, EG, and a height of 6, the two sides that meet at 90 degrees. So the area is 1/2 of base times height, half of 4 times 6, which is 12 square units. Then our last few examples. Example 6, an ice resurfacing machine is used to smooth the surface of ice at a skating rink. The machine can resurface about 270 square yards of ice in 1 minute. So right away I notice they're giving me units in square, so that gives me a hint I'm dealing with area. If it was regular units, that would be perimeter, square units are area. And then I know it's a rectangular shape, so because it says it right here. About how many minutes does it take the machine to resurface a rectangular rink that's 200 feet long and 90 feet wide? So the first thing I want to do is figure out the area of that rectangle. So length times width, 200 times 90, gives me 18,000 square feet. So our rink is 18,000 square feet of ice. Once we have the area, we can take the area and divide it by the rate of 270 square yards per minute. So 1800 divided by the 270 gives me 66 2/3 minutes, or approximately 66.7 minutes. Then example 7. They want us to use the area formula to find the missing side lengths. So both of these are dealing with the triangle. They tell us information and they want us to use that to find what's missing. So in part A, they told me the base is 28 meters and the area is 308 square meters. They want us to find the height. So we're using A equals 1/2 B times H, and we're solving for H. So we're going to replace area with the 308 square meters, replace base with the 28, and solve for H. So 1/2 times 28 gives me 14 times H equals 308. Divide both sides by 14, and the height equals 22 meters. Now, in part B, we're looking for the base. So they told us our area is 64 square meters, the height is 16. So we're going to set that up in the area equation and solve for B. So 64 is the area, equals 1/2 times B times our height is 16. 16 times 1/2 is 8. So 8 multiplied by B is 64. Divide both sides by 8, and we get a base of 8 meters. So this whole unit and section comes back to understanding these 4 figures and the 2 different equations for perimeter and area, or for circle circumference and area of each figure.